Good morning, dear students. Myself, Professor Kumbar Sagar Dinkar from Chhatrapati Shivaji Junior College, Pannala. Dear students, in the previous lecture or in the previous video, we studied the circular motion and three applications. The first is banking of rod, second conical pendulum, third vertical circular motion. Now, in this lecture or in this video, today we discuss what is a rotational motion. This is second part of the rotational dynamics. To study the rotational motion, initially, what is the definition of torque? Torque is nothing but the two equal magnitude, parallel forces acting on a body. Due to these forces, body possesses purely rotational motion. Then, the forces is called as torque. Means to rotate the steering of the car, there is a two forces are used. Both forces are opposite in direction. Both are parallel to each other. They act on a body at different points. Due to these forces, body possesses purely rotational motion. To rotate the steering, there is a requirement of torque. And physics says that when torque acting on any body, body possesses a purely rotational motion. I repeat again, what is a rotational motion? When torque acting on any body, body possesses a purely rotational motion. Now, best example of rotational motion. To open or to close the water tap, there is a requirement of torque. Again, to study the rotational motion, initially we study what is the inertia. Inertia is nothing but the mass. Before that, we know that the first law of Newton's linear motion. Newton's first law says that every body continues in its state of rest or state of linear motion until and unless unbalanced force act on it. मित्रांनो, कोणतीही वस्तू स्थिर असेल तर स्थिर राहते आणि गतिमान असेल तर गतिमान राहते कधीपर्यंत जोपर्यंत त्याच्यावर कोणतंही बाह्य बल बाहेरून आपल्याला अप्लाय केलेला फोर्स ऍक्ट होत नाही तोपर्यंत. म्हणून न्यूटन्स फर्स्ट लॉ कशासाठी युजफुल आहे तर टू स्टडी द मास. मीन्स व्हॉट इज इनर्शिया. इनर्शिया म्हणजे काय? Inertia is nothing but the opposed to the linear motion is called as inertia. This inertia represents mass in the linear motion. I repeat again, opposed to the linear motion is called as inertia, and this inertia represented by mass of the body. Now, by using this inertia, we easily determine what is moment of inertia. What is the moment of inertia? So we know that fan is rotating about its own axis. Now, when we switch off this fan, then this fan not stop directly. It rotating about its own axis continuously for small time. After small time, its rotation becomes zero or it stops to its rest position. This is occurs due to the rotational inertia. Means this motion opposed to the rotational motion. This concept is called as moment of inertia. Means opposed to the rotational motion is called as rotational inertia or moment of inertia. मित्रांनो, फॅन स्वतःभोवती फिरतोय. स्वतःभोवती फिरत असताना तो मी स्विच ऑफ केला. स्विच ऑफ केल्यानंतर तो लागलीच थांबत नाही. तो थांबण्यासाठी त्याला थोडासा कालावधी लागतो. मग तो थोडासा कालावधी म्हणजेच काय तर तिथे फॅन चे असलेलं मास रोटेट होणारं मास त्याच्या रोटेशनल मोशनला अपोज करत असतं. आणि रोटेशनल मोशनला अपोज करण्याची जी वस्तूची ॲबिलिटी आहे त्या ॲबिलिटीला फिजिक्समध्ये मोमेंट ऑफ इनर्शिया असं म्हणतात. जे इंग्लिशमध्ये बोललोय तेच फक्त मराठीमध्ये काय काय मी रिपीट केलेलं आहे. आता मला हे क्लासिकली शिकून चालणार नाही तर मला शिकायचं आहे की की मोमेंट ऑफ इनर्शिया मॅथमॅटिकली कशी प्रूव्ह करायची. तर आपल्याला माहित आहे की भारतामध्ये महर्षी कणाद नावाचे ऋषी होऊन गेले. महर्षी कणाद नावाचे ऋषी काय म्हणतात, एनी बॉडी ऑफ युनिवर्स फॉर्म ड्यू टू द स्मॉल पार्टिकल्स. नाउ नंबर ऑफ स्मॉल पार्टिकल्स बिकम्स टुगेदर टू फॉर्म एनी बॉडी. म्हणजे कोणती युनिवर्समधली बॉडी छोटे छोट्याशा पार्टिकल पासून बनते आणि अशी नंबर ऑफ पार्टिकल्स एकत्र येतात आणि एक रिजिड बॉडी बनतात. आता मला शिकायचं आहे की मोमेंट ऑफ इनर्शिया. मोमेंट ऑफ इनर्शिया शिकण्यासाठी मी ते कन्सिडर करतोय माझ्याकडे कोणत्याही आकाराची एक रिजिड बॉडी आहे. लेट अस कन्सिडर देयर इज अ वन रिजिड बॉडी ऑफ एनी शेप. नाउ this rigid body rotating about an axis passing through the point O means, let us consider this is duster of any shape. Now this duster rotating about its own axis and this axis of rotation passing through the point O. Here same concept, this rigid body rotating about an axis passing through the point O. But we know that this rigid body formed into the number of small particles. Number of small particles becomes together to form a small element. Let M1, this is a small element, a small particle of the rigid body situated at a distance R1 from the axis of rotation. Similarly, M2, this is the mass of the second particle. It is also situated at a distance R2 from the axis of rotation. Similarly, M3, this is the mass of the third particle situated at a distance R3. Similarly, Mn, this is the mass of the nth particle situated at a distance Rn from the axis of rotation respectively. I repeat this. Let us consider this is a rigid body of any shape rotating about an axis passing through the point O. Let M1, M2, M3, Mn are the masses of the particles of the rigid body situated at a distance R1, R2, R3, Rn from the axis of rotation respectively. Now, physics says that what is the moment of inertia of the first particle, second particle, third particle? Now mathematically it is represented as moment of inertia. It is a product of mass of any particle into square of distance between axis of rotation and the mass of the particle. Means, let us consider only first mass M1, which is situated at a distance R1. Then the moment of inertia of this first particle along this axis of rotation is equals to I1, and I1 equals, it is a product of mass of the first particle and square of distance between axis of rotation and the mass of the particle. Similarly, moment of inertia of the second particle is equals to I2, and I2 is equals to M2, mass of the second particle, and square of distance between axis and the mass M2. Hence, I2 is equals to M2 into R2 square. Similarly, I3 equals M3 into R3 square. Rn, this is a moment of inertia of the nth particle, and the moment of inertia of the nth particle is equals to Mn into Rn square. Hence, the total moment of inertia of the whole body when it is rotating about an axis passing through the point O is equals to I equals M1 R1 square plus M2 R2 square plus M3 R3 square plus plus Mn Rn square. This is a sum of moment of inertia of the all particles. Hence, by using mathematics, total moment of inertia of the whole body along this axis of rotation is equals to summation mi into ri square, where I goes from 1 to n. Hence, I repeat the definition of the moment of inertia. What is the moment of inertia? What is the definition of the moment of inertia in the mathematical method? Moment of inertia of any body about any axis of rotation is defined as it is algebraic sum of product of masses of each particle and square of distance between axis of rotation and the mass of the particle. This is a brief explanation regarding to the moment of inertia, its mathematical formula, and now we study what is the physical significance of moment of inertia. Now we discuss what is the physical significance of moment of inertia. Before that, I repeat the definition of moment of inertia. Moment of inertia, it is equals to algebraic sum of product of mass of the body and square of distance between axis of rotation and the mass of the particle. Now, what are the physical significance of moment of inertia? Initially we studied the first physical significance, which is nothing but the formula, unit and the dimension. What is the formula of moment of inertia? I is equals to moment of inertia and it is equals to mass of the body, mass of the particle into square of distance between axis of rotation and mass of the particle. Here we know that when any body performing a rotational motion, then all the particles of this rigid body performing a circular motion with different radii and different velocities. Now what is the unit of moment of inertia? In terms of SI, it is measured in terms of kilogram meter square, because mass is always measured in terms of kg and distance square means distance is measured in terms of meter square. Hence, its SI unit is kilogram meter square and CGS unit is gram centimeter square. Then what are their dimensions? Now, dimensions of moment of inertia are m raised to 1, l raised to 2, t raised to 0. Now, the second physical significance. This moment of inertia always depends on two quantities. One is depends on axis of rotation. As axis of rotation changes, moment of inertia changes, because distance between axis and the mass changes means axis of rotation changes. Next, the second is again this moment of inertia depends on size, shape and mass of the body. I repeat again, moment of inertia always depends on first axis of rotation and size, shape and mass of the body. Third physical significance of the moment of inertia is, we know that in the linear motion there is always mass which oppose the linear motion. But in the rotational motion, there is a moment of inertia which oppose the rotational motion. But again we know that in the mass or in the linear motion, there is a requirement of force. In the rotational motion, there is a requirement of torque. Hence, the force is equals to, by using Newton's second law, force equals mass into acceleration. And again we know that from the 11th standard, torque is equals to moment of inertia into angular acceleration of the body in the circular motion. Means From these three equations, we said that mass in the linear motion is analogous to, same as, moment of inertia in the rotational motion. Again, the force in the linear motion is analogous to torque in the rotational motion. Similarly, force in the linear motion is equals to mass into acceleration. It is same as or analogous as torque in the rotational motion, and the torque is equals to I into alpha. From this equation, we say that linear motion is analogous to the rotational motion. म्हणजेच मित्रांनो काय तर मास लिनियर मोशनला अपोज करतं ते सेम असतं कुणासारखं तर मोमेंट ऑफ इनर्शिया. मोमेंट ऑफ इनर्शिया काय काम करतो मोमेंट ऑफ इनर्शिया अपोज करतो कुणाला अपोज करतो रोटेशनल मोशनला. सेकंड थिंग लिनियर मोशनला फोर्स लागतो तो फोर्स सेम असतो कुणासारखा रोटेशनल मोशन साठी लागणाऱ्या टॉर्क सारखा. म्हणजेच मास एनालॉगस आहे मोमेंट ऑफ इनर्शियाला फोर्स एनालॉगस आहे टॉर्कला. मग फोर्सचा फॉर्म्युला काय आहे मास इंटू ऍक्सलरेशन हे सुद्धा सेम असणार आहे कुणासारखं टॉर्क इज इक्वल्स टू आय इंटू अल्फा सारखं. म्हणून मी पुन्हा डायरेक्टली म्हणेन हे सर्व एकमेकांशी जर एनालॉगस असेल तर लिनियर मोशन इज analogous to the circular motion, and the circular motion is again analogous to the rotational motion. Stop. Good day, dear students. Again, welcome in the Kumbarsar classes. Now, we studied the second article in the rotational motion or in the rotational dynamics. परीक्षेला मित्रांनो क्वेश्चन विचारला जातो obtain an expression for kinetic energy produced in the rotational motion. Means again repeat the question. Obtain an expression for kinetic energy produced in the rotational motion, or show that kinetic energy is directly proportional to square of frequency of the rotating body. Now, in the previous lecture, we studied what is the definition of moment of inertia. I repeat this definition again. Moment of inertia of any body about any axis of rotation is defined as, or it is equals to, algebraic sum of product of masses of each particle and square of distance between axis of rotation and the mass of the particle. Now, expression for kinetic energy. To study the kinetic energy, let us consider there is a one rigid body of any shape. Now, this rigid body rotating about an axis passing through the point O with constant angular velocity omega. I repeat again. Here, whole body rotating about an axis passing through the point O. But angular velocity of this body is constant. Let m1, this is the mass of the first particle, situated at a distance r1. Similarly, m2, this is the mass of the second particle, situated at a distance r2. m3, this is the mass of the third particle, situated at a distance r3. Dot 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 dot. m, this is the mass of nth particle, situated at a distance rn from the axis of rotation respectively. But we know that when any body performing a rotational motion, then each and every particle of the rigid body performing a circular motion. Means, due to this circular motion, there is a linear velocities are created. I repeat this. All particles of rigid body performing a circular motion with different radii means there is a linear velocity velocity is created. Now from the circular motion we know that the relation between linear velocity, radius vector and angular velocity, and it is equals to v bar equals omega bar cross r1, and its magnitude is represented as v is equals to r into omega. Now consider first particle whose mass is m1 situated at a distance r1. Now this particle performing a circular motion due to this rotational motion. Hence the linear velocity of this particle is v1. But physics says that this linear velocity is always tangential to the circular path. Hence the linear velocity of the first particle is equals to v1, and v1 is equals to r1 into omega. Similarly, consider second particle whose mass is m2 situated at a distance r2, and its tangential linear velocity v2 is equals to r2 omega. Similarly, v3 is equals to r3 into omega. Vn, this is the linear velocity of nth particle, is equals to Rn into omega. All this equation says that here omega is angular velocity of the particles, and this omega always remains constant in the rotational motion. Now this linear velocity gives a kinetic energy, and we know that the general equation of kinetic energy in the linear motion, it is equals to kinetic energy equals 1/2 mass of the particle into square of velocity of the particle. Now putting the values of velocities in this equation, we get kinetic energy of the first particle whose mass is m1, whose velocity is v1, equals 1/2 m1 into v1 square is equals to 1/2 m1 into bracket r1 into omega bracket square. Since v1 is nothing but the linear velocity of the first particle, is equals to v1 equals r1 into omega. Taking the square of r1 and omega, we get E1 equals 1/2 m1 into r1 into r1 square into omega square. I repeat again, kinetic energy of the first particle is equals to 1/2 m1 into r1 square into constant angular velocity omega square. Similarly, kinetic energy of the second particle whose mass is m2, whose radius of circular motion is r2, is equals to 1/2 m2 into r2 square into omega square. Now E3 is kinetic energy of the third particle is equals to 1/2 m3 into r3 square into omega square. Kinetic energy of nth particle is equals to 1/2 mn into rn square into constant angular velocity omega square. Now the total kinetic energy of the whole system, or the total kinetic energy of this rigid body when it is rotating about an axis passing through the point O equals. Hence, the total kinetic energy is the sum of all kinetic energies. Hence, E equals E1 plus E2 plus E3 plus En. Hence, the total kinetic energy is equals to E equals 1/2 in the bracket m1 r1 square plus m2 r2 square plus m3 r3 square plus mn rn square, bracket complete, into constant angular velocity omega square. Now we know that the general definition of moment of inertia, and the general definition of moment of inertia is nothing but the I is equals to summation mi/ri square, where I goes from 1 to n. Hence, the m1r1 square plus m2r2 square plus m3r3 square plus mn square is equals to I. Hence, the kinetic energy in the rotational motion I is equals to 1/2 I omega square. Now again we know that from the circular motion omega is equals to twice pi n. Hence, omega square is equals to 4 pi square into n square. Hence, the total kinetic energy in terms of frequency of the rotating body E is equals to 1/2 moment of inertia into 4 pi square into n square. From this equation we say that kinetic energy is always directly proportional to square of frequency of the rotating body. As frequency increases, kinetic energy of the rotating system also increases. Hence, E is directly proportional to square of frequency of the body. This is an expression for kinetic energy produced in the rotational motion. Again, physics says that this kinetic energy in the rotational motion is analogous to kinetic energy in the linear motion. From this equation we say that Lm is also analogous to the rotational motion.